Hello everyone, welcome in a new video. In this video, we are going to understand about a new scheduling algorithm which is a multi-level queue scheduling. Okay, so let's start. And multi-level queue scheduling is basically similar to all the scheduling we discussed previously. Um, in this scheduling algorithm, what basically we are going to do is we having multiple queues. We having we having multiple queues, and for the different queues you can apply different scheduling algorithm like SJF, SRTF, FCFS, whatever. Okay, so this basically have multiple ready queues, What does this mean? This means that let's say one queue performing some performing basically scheduling the process with a one particular type of algorithm, let's say round robin. Okay, let's say the q1 is basically about a system processes. Q1 is about a system processes. So they whatever the process available in this system one basically done by this RR round robin. Okay, this thing was done by this process is basically scheduled by round robin scheduling algorithm. Let's say we have one more queue. Okay, multi-level queue means so many queues were there and we have to perform some particular scheduling algorithm. Let's say Q2 is all about a foreground processes. Foreground processes. Okay, so and this thing was solved by some other scheduling algorithm, let's say SRTF scheduling algorithm. Let's say one more queue we have, let's say Q3. Okay, so Q3 is about background processes. Okay, Q3 is about background processes. This thing was solved by some different scheduling algorithm. So all the queues is basically solved by all the queues processes are basically scheduled by a different scheduling algorithm. This is what happened in a multi-level queue scheduling. Okay. And one more thing is Q1 is different, Q2 is different, Q3 is different. So what does this mean? This means that Q1 Q1 whatever the processes are available, we cannot switch that processes to other queue. Let's say that SRTF, let's say one schedule, let's give it a name like, okay, okay. So let's say that this Q1 is solved by one, let's say as Q1 scheduling algorithm. Q2 is solved by Q2 scheduling algorithm. Q3 is solved by Q3 scheduling algorithm. And let's say that Q2 scheduling algorithm gave us a best average turnaround time and best average waiting time. So in multi-level queue scheduling, whatever the process available in a Q1 cannot move to Q2. Okay, so this thing will basically happen in this case. Okay, and what the meaning of these processes? Foreground processes is basically whatever the thing you see, what are the processes you see on your screen is basically a foreground processes. Background processes means whatever the process is running in your background, this is called a background process. And system processes are basically like what your system is basically done, like operating system first of all run, what it should do, necessary thing basically come in a system processes. Okay, one more thing is there in multi-level queue scheduling algorithm that every queue have a different priority. Yes. Okay, every queue have a different priority. Let's say Q1, it is given in a question that Q1 having higher priority than Q2, having higher priority than Q3. So this thing is also given while you are solving question with a multi-level queue scheduling. Okay, one more thing that you need to remember that only one scheduling algorithm perform on a one queue. One scheduling algorithm, one scheduling algorithm per queue. One scheduling algorithm per queue. Okay, means if Q1 is performing round robin, so it always perform round robin till the completion of all the processes, till the termination of all the processes. Okay, it cannot switch the scheduling algorithm. For some time it use RR, for some time it use SGF, for some time it use different. So this thing is not happen in multi-level queue scheduling. Okay, so this is what basically happened in a multi-level queue scheduling. After now, the one more thing is that fixed priority preemptive scheduling method. This is basically a fixed priority preemptive scheduling algorithm. What does this mean? Fixed priority preemptive scheduling fixed scheduling method. Okay. Now, what does this mean? This means that every queue priority is basically fixed, because priority is basically of two types, static and dynamic. In this case, in this scheduling algorithm, the priority is fixed. Priorities are not changing. If the some process come, so if a process assign, okay, this much is the priority of this particular process, so it always it cannot change. Let's say that P1, P2, P3 have three processes. Okay, P1 having a priority like 1, 2 and 3, okay, in a sequence. So P3 priority is always 3 till the termination. Okay, P3 priority cannot change in this scheduling algorithm. Okay, so this is a very important thing. Preemptive means that if Q1 is some process from a Q1, some process from a Q1 is running. Let's say this is a Gantt chart. Okay, let's say that P1 is a process available on a Q1, P1 and P2 is a process available on a Q1, and in a Q2 we have a process like P3. Okay, so and the question says that Q1 priority is basically high. So first of all, what we have to do is we have to run Q1 processes, because the priority of Q1 is high. So when you run P1 from 0 to let's say 2, and arrival time of P2 process is also 2. So if this thing happen, then what you have to do is you have to provide CPU to P2 process. You have to provide CPU to P2 process. Let's say that after P1, because P1 is now not completing. P1 is, let's say the burst time is what, 4. Okay, this is what a burst time, and arrival time for the P2 process is 2. So add to yeah, now what you can see is that P1 process is not completed right now, so it cannot continue these things. Why? Because other highly prioritized because other process come at one particular arrival time. Okay, so this is what the meaning of a preemptive thing. We solved so many questions with the preemptive algorithms, so same thing happen in this case as well. So, and let's say that P1 and P2 processes are arrival time. Let's say the arrival time for P1 is what, 4, and P2 is what, 2. For for the Q2, the arrival time is 0. So at 0, here you can see that we know that Q1 is highly prioritized, but the processes are not there. So definitely what we have to do is we have to assign processor to the P3 process. So these thing happens. Okay, when we solve a question, we understand these things in detail. What you have to understand right now is fixed priorities are not changing, and it's a preemptive scheduling algorithm. If other process come one particular arrival time, then CPU have to be, operating system is providing CPU to that particular process. Okay, highly prioritized process is getting a CPU. And in this, time slicing is also there. Time slicing, what does this mean? What we basically, I explain you that Q1 process is running, and one particular arrival time Q2 processes are also can get the CPU. The Q2 processes also get the CPU at one particular time. Okay, so time slice is there for a Q1 and a Q2. Okay, and one more thing that you need to remember, that every process get fixed priority. Okay, so this is what this means. Fixed priority thing is every process gets a fixed priority, and a process from highly prioritized queue executed first. It says that Q1 is a highly prioritized process, highly prioritized queue, then Q2, then processes available on a Q1 will execute first. Okay, so this is what basically there. Okay, and this is how, now let's solve a question, and let's see that how these things basically work. Okay, so we have a question that Q1 having a value. Q1 is basically perform round robin scheduling algorithm with a time quantum of 2. Okay, so and Q2 is basically performing first come first serve scheduling algorithm. So the question basically describe that, okay, Q1, if the processes are in a Q1, then we have to do round robin scheduling algorithm. If a process is in a Q2, then we have to perform first come first serve scheduling algorithm. This is what processes, like we have 4 processes, P1, P2, P3 and P4. 4 processes are available. Arrival time of these processes are like 0, 0, 0 and 9. Burst time of the processes are like 4, 3, 9 and 4. And we have a now this is the important thing. P1 process are in a Q1, P2 process are in a Q1, P3 process are in a Q2 and P4 process are in a Q1. So in a Q2 we have only 1 processes and Q1 we have 3 processes. Okay. Now what we have to do is we have to make because it's a preemptive process, so definitely we have to make a calculation table for the burst time. So 4, 3, 9, 4, and now let's start. So for a Q1 and Q2, whatever the process are there, and we are basically adding that process. Now let's understand this thing, that how we are going to solve this. Okay, Gantt chart started from a 0. At arrival time 0, how many processes are available? 3 processes, P1, P2 and P3. 3 processes are available at arrival time 0. Okay, so we can choose processes from these 3. Okay, now what we have to do is the next, what basically our next step is, we have to assign the processes in a queue. So in a Q1 we have 2 processes, P1 and P2. We have to write in a sequence, P1 and a P2. And in a Q2, because in a Q2 there is basically one process available at 0 arrival time, which is P3. Okay, so now these things happen, and what we discuss in the intro, that highly prioritized queue will processes basically execute first, and in this case Q1 is a highly prioritized than Q2. Q1 is highly prioritized than Q2. So now what basically happen is, whatever the process available in a Q1 will execute first. So at 0, which process basically get a CPU? P1 is a process which get a CPU. If arrival time is same in a round robin, then what we have to do is we have to select a process according to their IDs. Okay, so 1 is definitely smaller than 2, so P1 process come first, or basically we have to follow FCF. Okay, P1 get a CPU from 0 to 0 to 4. If you are writing like this, then you are making a mistake. Why I said this thing? Why I said you are making a mistake? Because round robin is basically a time quantum thing. So we have to run it only on. We have to run this only two time quantum. Okay. So P1 process is run from 0 to 2. Okay. So the burst time left for the P1 process is what? Now P1 is completed. If P1 is completed, now we have to check in a round robin. What basically we have to do? We have to check at 2 arrival time there is a process is available. So no, there is no process available at 2. So if there is no process available at 2, then second thing what we are going to do, we are check that whatever the process we currently execute is having some is basically left some burst time, is basically is completed or not. We have to check this thing. So P1 is not completed yet, burst time is left too. So then we have to assign P1 in a queue as well, because P1 is now not completed. This is what basically do in a round robin. If you don't know about round robin, then you have to watch the videos that how we solve a question, how we solve this, how we basically assign the processes in a round robin scheduling algorithm. Okay, so at 2 no process available, P1 get a again in a ready queue. After P1, P2 processes, we are not executing P3 because Q1 is highly prioritized. So first of all, we have to execute the processes available in a Q1. So P2 get a CPU, run only 2 time quantum. So 4, the burst time left, yes, burst time left, which is 1. Now at 4 arrival time, there is a process is available. So the answer is no, no process is available at 4 arrival time. So no process available. Then we have the second step is what we have to check that whatever the process we run is completed or not. So P2 is not completed. So we have to again put in a ready queue. So P2 is again in a ready queue. Okay. So now the next step is the next process, which is P1. P1 get a CPU. P1 is getting a CPU. So from 4 to 6, and now you can see that at 6, because we have to run maximum 2 and the bus time is also 2, so we complete this process. Now P1 is what? Completed. So at 6, what we have to check? We have to check that new processes are there in a ready queue or not. So no, answer is no. And second step is what we have to check that P1 is completed or not. So P1 is completed, so no need to add anything. After that, the process we have is what? P2. So P2 get a CPU. P2, the bus time is what? 1. So from 6 to 7 it execute and the P2 is completed. P2 is completed. After the completion, what basically we have to check? We have to check that at 7 processes are come. So answer is no. Then we have to check P2 is completed or not. So P2 is completed. Now Q1 is empty. Q1 is empty. If there is no process in a Q1, then we have to select processes from Q2. Now P3 will get a CPU. Now the completion time for P3 is what? 9. Only 2 unit. Why I say this thing? Because at 9 arrival time, one process is available, which is P4. Okay. P4 process is available. So now what we have to do? P4 process available at 9, so we have to execute P3 only 2 unit. Now P4 process available and it is a Q1 process, so we have to add it in a Q1. Now what we have to do is we have to check that process available in a Q1. So answer is yes. If yes, then we have to select that process because Q1 is highly prioritized than Q2. So P4 get a CPU. The bus time for so P3, the bus time basically left is what? 7, because we run 2, 7 to 9. Now, the bus time for P4 process is what? 2, but in a Q1 we have to apply a round robin. So the time quantum is what? 2, so we have to execute it only 2 units, so 9 to 11. The bus time left is what? 2. Okay. After that, what we have to do is we have to check that process available in a Q1 or not. So after that, what we have to do is P4 at 11, we have to check that new process are available or not. So no new process. We have to see that P4 is completed or not. So answer is not completed. So we again add in a queue. So P4 is again in a queue. After that, we have to check that Q1, there is process in a Q1. So answer is yes, P4 is there. So we have to execute P4 again till now the time quantum is 2. And here you can see that the bus time is also 2, so it execute completely at 13. It completely executed 13. Okay, so most of the student what it do is basically from 9 to, it directly write 9 to 13, not 9 to 11 and 11 to 13, directly 9 to 13. So this is a mistake. It's a round robin scheduling algorithm. Time, if there is a time quantum, you cannot exceed that time quantum. Okay, whatever the time quantum is, you can maximally use that CPU to that particular time. Okay, if you write like 9 to 13, you basically remove one context switch. Okay, so this thing happen. Okay, so be careful while you are solving a question with a round robin scheduling algorithm. Okay, so after that, now P3 at 13 processes, new processes are there, so no new process. Then we have to check P4 is completed or not. So P4 is now completed. P4 is now completed. So if completed, no need to add in a Q1. After that, we have to check that processes is there in a Q1 or not. So answer is no. No processes is there in a Q1. Then we have to check Q2. So process available in a Q2. So answer is yes. P3 is there. What is the bus time left for the P3, which is 7. So we have to again execute full because we know that no new processes are there. Only one process left, P3. So P3 is now executed and the completion time will become 20. Completion time will become 20. So this is how multi-level queue scheduling algorithm is basically solve a question. Okay, we solve a question with a multi-level queue scheduling in this. Okay, here in this question we have 2 queues, some question 3 queues is also there. So you have to be very careful while solving question, this type of a question. Okay, so this is how basically you are going to solve. you are solving this question with a priority thing. Which queue is higher priority, you have to select processes from that queue first and then the lower prioritized process. Now we talk about the disadvantage. Let's talk about a disadvantage of this scheduling algorithm. So this scheduling algorithm is basically, some process may starvation, some process lead to starvation. Okay, some process may starve for what? For CPU. If what happen, let's say that what happen if some highly prioritized queue are never become empty. What is basically there is means Q1 process, in a Q1 every time the process is there, okay, Q1 is never become empty, then whatever the process is available in a Q2 will never get a CPU. So the processes in a Q2 will become starved. Basically starvation things happen in a Q2 processes. Okay, so if for CPU, if some highly or higher prior if some higher prioritize highly priority queue are never becoming empty. So this is a disadvantage of the scheduling algorithm. And the other another disadvantage is that it is inflexible in nature. It is inflexible in nature. What is the meaning of a inflexible in nature? Inflexible in nature means that you cannot shift the processes from a Q1 to Q2. Like for example, let's take an example to understand this thing. Like Q1 having a process P1, P2, and P3, and Q2 is a process is having P4. Okay, so you cannot shift one process from another queue to another queue. Let's say that you have to shift P3 to Q2, which is P3 is available in a Q1, but you have to shift P3 in a Q2. So you cannot do these things. It is an inflexible in nature. Okay, so you cannot shift the processes from a one queue to another queue. Okay, so this is a disadvantage of this scheduling algorithm. So I hope you understand about the multi-level queue scheduling algorithm. Okay, this is all about this scheduling algorithm. Like the video and thanks for watching this video. Like the video and subscribe my channel.